Hi guys, welcome back. So another data analysis video. I'm still recording a series of videos about probability distributions. But what I'm going to do in this video is I'm not going to talk about any specific probability distribution or discuss the parameters for it. Because one of the other things I'm trying to demonstrate with this series of videos is how we could simulate or generate random data that we could use to practice analyses, things like that, using Python. So all I'm going to do in this particular video is kind of demonstrate how you can simulate a data frame. So I've already demonstrated this in previous videos with generating individual variables and then stitching them all together as a pandas data frame. And there are several ways to simulate data and data that follows certain distributions. So we can specify if we wanted to follow a normal distribution or a binomial or something like that. But what I'll do in this video is I'll use a package called Faker. So this is a really interesting package. I think package is the appropriate name for it. I don't think it's a kind of a software library as such. But I'll use something called Faker along with numpy and pandas to simulate different types of data and then combine them all together in a pandas data frame. So I thought this kind of an interesting example. I kind of found out about Faker online and checked it out, and it is a very easy way or a good way to create or to simulate data that you might want to use to practice different analyses. So I'm going to import some libraries to start with. I'm going to import pandas as PD, numpy as NP, and I'm also importing Faker as FK. So I've already installed Faker within kind of the Python environment that I'm working in. So so you need to do that to use Faker. If you don't have it, it's not part of the base environment. It's not automatically installed. You would have to kind of look up and either pip install it or install it from somewhere like CondaForge, depending on the environment or the software that you're using. Okay, so I'm then going to initialize a generator to create some fake data using Faker. I'm going to call this, I'm basically going to create an object called fake. And remember, I gave Faker these initials as FK. And I'm going to call FK, so I'm going to call Faker dot Faker with a capital letter. So like that's going to be a method that exists within the Faker package, so to speak, or a function that exists within the Faker package. So next what I'll do is I'm going to actually manually define a function to create some fake values and variables. The proportions and associated list of values for participant status, partic status here, this kind of P here gives the proportion of each of the status list categories. Okay, so let me talk through this. Hopefully this will be a bit clearer. So I'm using the def keyword, reserved word. So I'm creating a new function. I'm calling it make participants, and it takes as an argument the number of participants you want to create. And I'm telling it specifically to create data for certain variables. So first of all, I'm going to create some lists to randomly assign to participants. First one I'm calling status list. So let's imagine where we've got data here. Maybe it's from some company, it's about people's employment, that type of thing. So I've created one called status list, which records whether someone's full-time, part-time, or hourly employed, so casually employed, so to speak. And then I'm creating another called team list. Okay, and we'll see what that does in a sec. So it's basically gonna allocate them to a team using a color name. So they'll have the red team, the blue team, that type of thing. Yeah. And I'm using, in order to do that, you can see within the list here. So for status list, I've just passed 3 strings. The list contains 3 items, full-time, part-time, hourly. For team list, I'm basically using fake.color name. So Faker obviously has access to a palette of colors that you can run through for X in range 4. So it's basically just gonna it's going to select 4 color names essentially and run through that. So 4 teams with different color names. And then what I'm doing is creating another list called fake participants, and it's going to create a series of variables. So you'll notice within this list I've passed the dictionary, hence the curly braces, each with key value pairs, stating which variables we're going to create. So we're going to create a participant ID variable, and that's just going to be kind of like, it's going to be the Python index plus 1,000, so 1,001, 1,002, that type of thing. It's completely made up, but it kind of provides a unique identifier for each participant. And then this is kind of one of the really interesting things about Faker, is we're going to create a name for each of our participants. So participant name, and we're using Faker fake.name essentially. So it's going to generate a load of fake names, first name, surname, essentially. I'm not sure how that works. There's obviously, I'm not sure what's going on in the background for it to do that, what the functions and the code look like, but that's quite interesting that it can do that. And then we'll create a variable called task date, and then we'll just specify date between start date. We're going to get a -1 year, whatever the date is, -1 year, end date today. So it's going to just return a date, start date, end date type of thing. Or it's going to return a date between today's date and a year ago. Sorry, that's my phone beeping. And then we're going to create a score. So maybe the score is what we'd use if we're doing some sort of analysis as our, it might be this, whatever this score relates to. It could be our dependent variable, and that's just going to be a normally distributed variable essentially. So I'm using the np.random.normal. We're specifying a mean of 5, a standard deviation of 1, and a size of 1. So what I'm saying here is the size is important. This is basically just going to return. It's going to iterate through each. When we get to this for loop, you'll see why that's working. It's going to iterate through each of our participants, whatever number we specify of participants we want, and it's going to return one numeric decimal floating point number for each. If we'd have specified a larger one, it would provide for each participant, it'd provide a list of, if this was four numbers separated by commas within square brackets. And then participant status, we're basically doing np.random choice. So we're randomly allocating our participants to these statuses, full-time, part-time, hourly, using our status list. And we're doing it within p equals 0.5, 0.3, 0.2. I kind of covered that up here in this note. So that p and the associated list of values, which is status list, for the participants, so it gives the proportion of each of the status list categories. So what it's going to do is probably about 50% of our participants will get full-time, 30% part-time, 20% hourly, something like that. And then team, same thing again. We're using this random choice. We're basically asking NumPy to randomly allocate them based on the team list. So it's going to allocate them to a team of a certain color. And you notice after the curly braces, those are that we've passed that dictionary of the variables, key value paired variables that we want. And then we've got for x in range num, and num is what our function make participants takes as an argument. Okay. So the thing it will then return is our fake participants data. So essentially a data frame. Okay, and then that it's going to return this data for each participant, and then we're going to create a data frame essentially. So we're going using this function. We're going to create an object called participant data frame, and we're using the pd.dataframe method. And notice what we're passing is we're calling this function make participants, and we're specifying we want 1,000 observations, 1,000 participants. And then all I'm doing here at the bottom is just kind of printing out the head, the first kind of few lines of that data. So let's run that and see what it looks like. And there we see, quite interesting. Okay, the team names are quite amusing, I guess. So yeah, quite interesting what it's done. So here we've actually created an object and used this function for 1,000 participants, wrapped it within the data frame object, and you can see here each participant's got an ID number, 1001, 1000, 1000, 1001, 2, 3, etc. It's got a name that's been made up. Brian Hubbard MD, apparently. Amanda Reed, this completely made up names. So I'm intrigued to know how that works exactly. Task date, so there's a date on there, 1st of the 5th, 23, 7th of the 2nd, 23. So that date, task, whatever the task date, that obviously their score maybe relates to. It happened between a year ago and today, and it's given it like a date time stamp essentially. Score, as I said, we just asked for a size of 1, so just 1 score per participant, and that's what it's done. They're kind of floating point numbers, and they're quite precise, but 5.4s. So we could have probably specified it that we wanted this to be, round it to kind of 2 decimal places or something. That might have been easier. But like I said, if we'd have changed this 1 here to 2 or 3, it would have returned, for each participant, it would have returned 3 scores essentially. And then you can see we've also got our participant status, so part-time, hourly. Can't see any full-time on there, but they are in there as part of our list. And then the colours, team colours, they've allocated them to a team of different, and each team is represented by a colour. Olive drab, hot pink are the 2 that we can see there, so they're quite interesting. I'm not sure what other colours it's used. We could have printed the full data frame, I guess, to see what it looks like, but that gives you an idea. So this is what we can see here is that using Faker, numpy, and pandas, we've created a quite sophisticated, quite complex data frame containing different types of variables. So scale variables, categorical variables, datetime variables, objects using people's names, things like that. For 1,000 participants, so really easy and really quickly, and we've put it all together as a neat data frame. So this, it kind of demonstrates how useful it can be to be able to simulate and generate data like this, to then use it for some sort of analysis. And you can we've got to specify many more kind of parameters about the types of distributions we wanted, based on what we were trying to examine or investigate. Okay, so that is an example of simulating data using numpy and using pandas and using this Faker package, which I think is quite cool. And to use it effectively, we could have created fake data for one individual quite easily, but to create a large data frame, all I had to do really was sort of create this new function that provided a list of variables and then iterated through that list. Okay, right, hopefully that was useful and interesting. As I've said in previous videos, I'm including a lot of information on how to generate and simulate random data, because it's when you're trying to learn, or when you're trying to practice running analyses, or when you are trying to do some sort of investigation where it's important you kind of understand the distributions of data. It's quite useful. It's quite useful for someone like me that teaches in higher education. If I want a data set to use for some sort of analysis, such as an ANOVA or a regression, it's not always easy to find data sets that are suitable, of the right size, to demonstrate the things that you want to demonstrate. But you can overcome that using these types of methods to kind of generate random data, essentially. Okay, hopefully that's useful. Thanks for watching and listening.